Hey guys, I wanted to review with you for your test tomorrow. We're talking about motion and forces. You have your packet with you and it has everything you need in it, but I wanted to review a few questions with you just to prepare. For example, which car is accelerating? We know if something is accelerating, it has to be changing its speed, going up or down, or its direction. Either or. If it's going in circles, it's accelerating. If it's speeding up, it's accelerating. If it's slowing down, it's accelerating. So a car that is not moving, we know that's not accelerating. A car that is going around a curve at a constant speed, well, you know when you go around your curve that you are definitely turning directions, changing your direction, so that would be accelerating. A car that moves in a straight line at a constant speed, same direction, so not accelerating. And a car that is going 60 miles an hour doesn't tell us it's changing anything. So it has to be the one going around a curve, okay? Newton's first law of inertia. Remember, his first law is an object at rest stays at rest, or an object in motion stays in motion. So the first thing says a ball sits motionless on the ground. That is at rest. That would be his first law. Okay, remember action and reaction. That's Newton's third law. So an action force is what you do. So it says the runner pushing against the air. You don't really push against the air. That's not going to make you do anything. The wind pushing against the runner's face, that might be a reaction, but that's not the action. The runner's feet pushing against the ground. Wouldn't you all agree you have to push your feet against the ground in order to move? So that would be the action force. All right, look at this tug of war. It says two platoons line up. If they both have the same amount of participants, what could be critical to them winning? Well, their age isn't going to matter. You could be older and strong or younger and weak. The height still is not going to affect who pulls harder. The total mass of the team. Remember, your force is equal to your mass times your acceleration. So if these guys are a lot bigger than these, they are going to pull harder. So yes, that would matter. Another one about accelerating. A lamp standing motionless. That cannot be accelerating. No change in speed or direction. A ball on a string whirled in a circle at a constant speed. Now, constant speed may throw you off, but think about it. It is going in a circle, changing direction. So that would be accelerating. The difference between speed and velocity. Speed is distance divided by time, and so is velocity. They're the same formula. However, velocity includes your direction. So 50 miles per hour would be your speed, but 50 miles per hour north, south, east, or west would be your velocity. So velocity includes rate of change and direction. Okay? A race car driver goes around a track with a speed of 110. So is he accelerating? Yes, because he's going in a circle. He is changing his direction. So the speed is constant, but the velocity is going to be changing. You can be on cruise control driving in a circle, and you will still be accelerating because your velocity is changing, but your speed may be totally the same. So if I go 70 miles per hour, that's my speed, and direction north. Speed and direction is velocity. Okay, on a carousel, constant moving the carousel around the center can best be described as acceleration because we have a change in our direction, our velocity. An object in motion will stay in motion unless acted on by what type of force? Remember, what type of force has to be acting on something in order for it to move? It has to be unbalanced. Newton's first law says an object will move what unless acted on? It will move not with constant acceleration, that means speeding up. Not with deceleration, that means slowing down, but in a straight line. It's going to keep moving in constant motion. Two forces acting on a wheelbarrow. One is pushing to the right and one is to the left. If we've got equal and opposite forces, it is not going to move. Remember, imagine you and somebody equally as strong as you pushing against each other on opposite sides. It would not move. All right, look at this distance versus time graph. It says during which period is someone not moving. If your distance is staying the same, you are not moving. So let's look right here. Distance is changing, but here distance is staying the same. So somewhere around 2, and we see from 1.5 to 2, that looks like that. They would not be moving. Okay, another displacement versus time. Where are we not in motion? Remember the flat part. So let's look at the seconds down here. This is between 5 and 10. Do we see a second between 5 and 10? Yep, I see this one. So that would be when you were not in motion. All right, an empty truck fully loaded and a fully loaded truck are next to each other. One is obviously going to weigh more, the fully loaded one. When the light turns green, the lighter truck increases speed more quickly. Why? It has to do with the mass. And remember, which law has to do with the mass? Newton's second law. Okay, last thing, rocket engine. Now, we see an engine pushing forward, an exhaust pushing backwards, an action and a reaction. Which law was action or reaction? That would have been Newton's third law of motion. Okay, so go back through this video, review these problems, make sure and pause it and look at those that you don't understand, and let me know if you have any questions.